The Azeri, Chirag and Ganashli developments are operated by BP for AIOC and have their shore base in Baku, Azerbaijan. The oil and gas fields are approximately 120 kilometers offshore southeast of Baku in the Caspian Sea, in 100 to 400 meters of water. The production zones cover an area of approximately 420 square kilometers, are located 2,500 to 3,000 meters below the seabed, and contain an estimated 4 billion barrels of oil, gas and condensate. DQ platform-based production systems have a processing capacity of 490,000 barrels per day or 24.5 million tons per annum. It will also process the production from the associated fields that will be fed in from a tied-in flow line at a later stage in the overall development. The AGC-1 is the first of many green developments and will use a cutting slurrification and injection system for disposal of drilling debris. The slurry is pumped from the rig through a hose into a subsea tree and injected into carefully selected geological areas. The self-contained system avoids the cuttings being shipped ashore, known as skip and ship, where they require further cleaning and disposal. Oil and gas will be brought ashore along independent subsea pipelines to a new terminal, from where it will be exported down a new 1,750 kilometre long pipeline known as the Baku-Tbilisi-Ceyhan line through Georgia to the Turkish Mediterranean port of Ceyhan. A choke is an adjustable device calibrated in CV, short for controlled velocity, which allows the production rate passing through to be varied within certain parameters, thus giving a measured flow rate. All valves are the ABB VG300 series slab gate valve with 5 1/8 inch valves used for production and 2 1/16 inch used for the annulus, with all valves configured to provide a fail-safe closed mode of operation. The tree arrives on deck protected from shipping damage by shipping bumper bars, which are removed prior to assembly of the two halves of the protective structure, which are shipped separately. Should a wear bushing be required, then this will have to be pre-installed and tested onshore, as it's difficult to install offshore unless being done below the rotary table. The tree may be deck tested at this time if required, and this can be carried out with or without the protective structures in place. For testing the workover control system, the basket jumper is used on both the run and production positions as required. This removes the need to continually move the EDU plate between the basket and the UGF. The overtrawlable protective cover may be fitted before or after deck testing at an appropriate time and preferably prior to moving the tree into the moon pool area. Once deck testing is completed, the tree is placed onto suitable skids such that the load is supported off the deck for safe gasket changeout. The lifting and handling tool is then removed by first removing the red anti-rotation key and rotating 5 turns to the right. The TRT inner string is then made up to the tree with 5 turns left hand. The UGF is installed around the TRT inner string and the TRT jumper made up to the tree run position. The control pod jumper is placed in the park position and the run and production protectors are installed onto the UGF. The EDU plate may be made up to the UGF and the run position functions checked to ensure correct termination of the TRT jumper. If the tree is to be lifted into position rather than utilizing a deck skidding system, then the anti-rotation key should be placed into the top of the cam-actuated running tool, and the top half of the quick make-up sub is removed by releasing the union nut and picking straight up. The tree is positioned over the moon pool and supported by the spider beams. The guidelines are fitted into their slots and held in place by the line traps. Once in the moon pool, the TRT anti-rotation keys must be removed if installed, along with the structure safety R-clips. Once under the rotary table, the quick make-up sub can be lowered down through the rotary and made up to the lower half by simply engaging the castellations and making up the union nut. The EDU is made up to the UGF and the weight of the umbilicals supported by a BOP pod line attached to the UGF. The tree can now be picked up a few feet, the spider beams retracted to expose the open moon pool, and the assembly quickly run through the splash zone. As the tree is lowered to the wellhead, the umbilical is clamped to the pod wire to support its weight. The tree funnels capture the wellhead posts, and the tree is guided to the final position where the tree connector engages over and lands out on the 20-inch housing. Correct landout can be visually checked with a black indicator line on post number 1 of the flow base. The lock function is now activated with 3000 psi, and the indicator is observed moving to the lock position. An overpull confirms the connector function, and the VX gasket test proves the integrity of the metal gasket seal. After a satisfactory test, the tree flow line connector is locked and full travel is confirmed by the ROV visual indicators. The ROV now moves the umbilical from the run to the production stab plate to allow for the tree valves to be function tested and then left open so that the flow line gasket and tree body envelope can be tested. On completion of these tests, the run protector on the UGF is moved down to the run position. The TRT jumper moved up to the UGF, and the production protector moved from the UGF to the tree production stab plate. The cam-actuated running tool is now released by rotating the stem 5 turns to the right. On pickup, the TRT assembly will come free of the tree mandrel and is recovered to the surface. Prior to installation of the cuttings re-injection hose and control umbilical, a pull wire needs to be established between the rig and a suitable clump weight on the seabed. This will aid the umbilical installation and provide an anchor point for the umbilical. The cuttings hose and control umbilical is to be assembled into the deployment tool at surface. The buoyancy block is attached and tied back to the umbilical. A sacrificial weight is also attached to the tool to aid its deployment to the seabed. Once the ROV has monitored the lowering of the deployment tool to the seabed, the buoyancy retaining strop will be cut. A sacrificial weight can now be released by the ROV. The cuttings hose will now be in the correct near horizontal position. The ROV now guides the deployment tool towards the cuttings tree. As required, additional cuttings hose and umbilical will be paid out from the surface, thus controlling the height of the hose from the seabed. When the ROV positions the deployment tool into the locating receptacles on the tree, the longer pin on the deployment tool is located first. The tool is then rotated into correct alignment with the second pin, before finally landing out the tool. Once the deployment tool is located onto the tree, the ROV will remove the safety locking pin. This allows the ASCA connector to be stroked forward into the tree using the specifically designed stroking tool. Once located into the tree, the stroking tool will be reversed to check that the ASCA connector is fully mated to the tree. The ROV then uses its manipulator on the ASCA connector to perform a pull test that confirms the connector is fully mated to the tree. Now that the connection at the tree is completed, additional umbilical is paid out and laid on the seabed. At the same time as the umbilical is being deployed, buoyancy is added to the hose as it leaves the rig on the surface. At a predetermined point, the messenger wire attached to the clump weight earlier will be connected to the umbilical on the surface. This will be used to pull the umbilical towards the clump weight on the seabed. The wire is pulled through a sheave on the clump weight. This procedure is monitored at all times by the ROV. Once the pull-in is completed, the tether point of the umbilical will have reached the clump weight. The ROV will now attach tether strops from the umbilical to the clump weight. The messenger wire and sheave wheel can now be retrieved to the surface. After the umbilical is tethered, the ROV flies along the laydown route back to the CRI tree. Further umbilical and hose will continue to be paid out with buoyancy added as required. The required compliant wave is now formed. This wave counteracts any vessel movement in adverse weather conditions. The ROV connects the hydraulic control jumper by moving the jumper from the park position on the deployment tool and onto the tree. The ROV then connects the electrical pressure sensor by moving the connector from the park position on the deployment tool and onto the tree. Once the connections are completed, the ROV will conduct a general inspection of the entire installation. This survey will include the tree connections, the umbilical laydown, the clump weight attachment, and the umbilical compliant wave. When all installation work has been carried out, the CAC tree installation system becomes the permanent operating controls and will be used and serviced by competent members of the rig crew. The system will maintain a minimum holding pressure of 1,500 psig on all valve actuators and 7,500 psig on the SCSSV. Since all valves adopt a fail-safe close policy, any loss of operating pressure will result in valve closure. Another feature in the system is the provision of a communication line using twisted pair technology, which is incorporated into the umbilical and is ROV friendly. This provides continuous annulus monitoring during the slurry injection periods, thereby giving live data to the controller so that full well control and safety practices can be maintained.